For today's meeting, you're not gonna cover like a lot of theory because um, I think this is gonna be more of an introduction to 3 points in space and
What do you mean?
basically three-dimensional coordinates.
Oh yeah.
Yeah, like this. And then if you have,
Mm-hmm.
for example, a point right here, let's just call this point A. And this is x, y, z. Yeah, and then the point would have like x, comma, y, comma, z. And some of the basic things you need to know is that when you have maybe like 2 points, let's just say this is x1, y1, z1, and then point B is x2, comma, y2, comma, z2. Um, these points sometimes they usually have this thing called distance, and a way for you to calculate it is to have the square root of x. No, I mean, you can do x1 minus x2 plus y1 minus y2 plus z1 minus z2. Apologies for the, it was upside down. And then you should square all of them. And this is how you find the distance. I don't really have a like possible explanation of why this is the case, but let's just think of it this way, because I feel like this is like a more wider version of Pythagorean theorem in some way. So you have the distance, and then you also have the midpoint. So to find the midpoint of A and B, you just add the two values of each coordinate and divide them by 2, like x1 plus x2 over 2, comma, y1 plus y2 over 2, comma, c1 plus c2 over 2. And that is pretty much it. So when it comes to like 3D space, sometimes there are questions in the exams that will ask you to find, for example, the area of maybe something like the area of this kind of rectangular prism. And so in this case,
Volume, right?
yeah, the yeah the sometimes they would ask you to find the volume of it, or they can also ask you the surface area or anything in general relating to the shape of the, the the shape that the points make. And so this is where you link back to the volume formulas, or calculating volume, surface area in general. Um, and the way you do it is first you find by finding the distance of these points, it can help you find um, the lengths of these shapes, the base, the height, the length, or anything you need when it comes to like looking for the volume of them or surface area of them. And then there's also trigonometry in 3D space. That would be seen in the case when you have to find, for example, um, between like the shape, there's like a triangle, and then you have to find their let's just draw this in another color. So see, here, there's a triangle. And then you have to maybe like find the angle of it, or you have to find the angle of this, and etc. etc. And that's when you apply trigonometry into it. So it's just like at this point, it's just applying the things you already know into the 3D space. So I think to get a better like understanding or better implementations of it, it's probably better to go into the book and do some questions.